At 11:03 a.m. on August 17, 1942, 12 B-17 Flying Fortresses crossed the English Channel at 23,000 feet and dropped bombs on a Nazi railway marshalling yard in Rouen, France. The mission lasted 53 minutes. All 12 aircraft returned. It was the first American bomber raid over occupied Europe, and it proved one thing that Allied planners had debated for 2 years: strategic bombing could work. What it did not prove, what nobody in that briefing room dared say aloud, was whether America could build enough bombers to actually win. On that August morning, the United States Army Air Forces owned fewer than 1,800 combat-ready aircraft total. Germany had more than 4,000. Japan had nearly 3,000. American factories were producing roughly 700 planes per month across all categories. Military planners calculated that defeating the Axis powers would require 185,000 aircraft before the war ended. At the current production rate, that number would take 22 years to reach. The answer to that impossible arithmetic came not from engineers, not from generals, not from the White House. It came from a man who had spent his career building cars, who had never built an airplane, who looked at the largest factory ever conceived and decided it still wasn't big enough. His name was Charles Sorensen, and the building he was about to construct in a Michigan farm field called Willow Run would become the most productive manufacturing facility in human history. The math that couldn't work. The problem was not ambition. America had plenty of ambition. In January 1942, 6 weeks after Pearl Harbor, Franklin Roosevelt stood before Congress and delivered production targets that stunned the room into silence. He called for 60,000 aircraft in 1942. Then 125,000 in 1943. Total. Not combat aircraft. Not bombers. All aircraft. The number included trainers, transports, observation planes. Still, the goal required increasing American aircraft production by a factor of 10 within 12 months. The Army Air Forces needed a specific aircraft above all others, the B-24 Liberator, a 4-engine heavy bomber designed by Consolidated Aircraft in San Diego. The B-24 could carry 8,000 pounds of bombs. It had a range of 2,100 miles. It could fly at 28,000 feet, above most anti-aircraft guns. It was, in the spring of 1942, the most capable bomber America had ever designed. It was also extraordinarily complex. Each aircraft contained 1,550,000 parts. The fuselage alone required 30,000 rivets. The electrical system stretched 8 miles if you uncoiled every wire. Consolidated Aircraft, the B-24's manufacturer, employed 45,000 workers and produced 60 aircraft per month. The Army needed 650 per month by 1944. No single factory anywhere in the world had ever produced aircraft at that rate. Henry Ford believed he could. His engineers were less certain. In December 1940, a year before Pearl Harbor, Ford Motor Company received a government request to review the possibility of manufacturing B-24 components. Ford's production chief, Charles Sorensen, flew to San Diego and toured the Consolidated plant. He watched workers move from station to station, carrying parts in their hands, consulting blueprints thumbtacked to boards. Skilled craftsmen built each aircraft from start to finish in a single location. The process was meticulous. It was also, by Sorensen's estimate, approximately 40 years out of date. Sorensen returned to Detroit and did what Ford engineers did with every manufacturing problem: he drew an assembly line. Not a modification of existing methods. Not an incremental improvement. A complete reimagining of aircraft production based on automotive principles. Parts would move to workers, not workers to parts. Each station would perform one specific task. The completed aircraft would emerge at the end of a moving line, built the same way every time, by workers who had mastered a single operation rather than an entire craft. Sorensen estimated his method could produce 1 B-24 per hour. His own engineers told him it was impossible. A building designed around a dream. The site chosen for the new factory was 1,200 acres of farmland near Ypsilanti, Michigan, 27 miles west of Detroit. A small creek called Willow Run crossed the property. The name would become the factory's identity and eventually a verb, to Willow Run, meaning to achieve something that shouldn't have been possible. Construction began in April 1941, 9 months before Pearl Harbor. The original design called for a building 3,200 feet long and 1,280 feet wide, more than half a mile in length. The roof covered 67 acres. The floor held 1,600 pieces of production equipment. Workers poured 58,000 cubic yards of concrete. Steel erectors raised 6.5 million pounds of structural steel. Electricians installed 160 miles of wiring. Plumbers connected 7 miles of pipe. The building cost $47 million to construct. The machinery inside cost $65 million more. There was one problem that no blueprint could solve. The factory sat directly on a county line. Washtenaw County allowed African American workers. Wayne County, which contained the final section of the assembly line, did not legally, not practically, not in the customs and agreements of 1941 Michigan. Rather than fight the political reality, Ford's engineers did something astonishing: they bent the assembly line. Literally. The final 860 feet of the production floor turned at a right angle, keeping the entire process inside Washtenaw County. The building's distinctive L shape, which visitors and historians have described as evidence of poor planning, was actually a monument to the racial geography of wartime Michigan. The bend cost $2 million and added significant logistical complexity. It saved the workforce integration that the factory would later depend upon. By the time construction finished in June 1942, Willow Run was the largest room under one roof in the world. Charles Lindbergh, who toured the facility that summer, called it a sort of Grand Canyon of the mechanized world. A journalist visiting from Life magazine described the sensation of standing at one end and looking toward the other as similar to standing on a runway and watching the horizon. The building did not feel like a factory. It felt like geography. Teaching farmers to build bombers. The aircraft that rolled off the Willow Run line began their existence 1,700 miles away in San Diego, where Consolidated engineers had spent 4 years perfecting the B-24's design. Each bomber required 313,000 engineering man-hours to design. The technical drawings, stacked flat, stood 7 feet tall. Ford received a set of blueprints and was told to reproduce them exactly. The problem was that Consolidated had designed the B-24 to be built by craftsmen. Ford needed to build it with assembly workers. The first B-24 rolled off the Willow Run line on September 10, 1942. It had taken 16 months from groundbreaking to first aircraft. The workers who built it were not aircraft workers. They were former automobile assembly workers, farm laborers, store clerks, and domestic servants who had answered recruitment advertisements posted in small-town newspapers across Michigan, Ohio, Indiana, and Kentucky. The ad copy was direct: no experience necessary. Good wages. War work. Many of them had never seen an airplane up close. Ford's training system divided the B-24's construction into 12,000 discrete operations. Each worker learned between 3 and 7 operations. A worker responsible for riveting the left wing spar never saw the right wing spar. A worker installing fuel system components never touched the electrical system. The training for each operation lasted 2 weeks. Instructors were drawn from the automotive industry, men who understood how to teach complex tasks to workers who had no background in mechanical work. By November 1942, Willow Run employed 12,000 workers. 6 months later, the number had doubled. By mid-1944, 42,000 people worked the factory's 3 daily shifts. The workforce that built America's bombers was not the workforce that pre-war America would have predicted or welcomed. Women made up 42% of the Willow Run workforce at peak production. They operated drill presses, operated overhead cranes, installed hydraulic lines, and inspected completed aircraft. The media called them Rosie the Riveter, a generic name for a specific revolution. At Willow Run, the revolution had a precise address: Building A, Station 9, Shift 2, where a former grocery store cashier named Rose Monroe drove rivets into B-24 fuselages and was filmed doing so for a government propaganda short that was later seen by 20 million Americans. African American workers came to Willow Run from Alabama, Mississippi, Georgia, and Tennessee, drawn by wages that were 3 times what they could earn at home. The factory paid equal wages to all workers doing equal work, not from principle, necessarily, but from practical necessity. The production line could not function if some stations moved faster than others. Equity on the line was a mechanical requirement. By 1944, 15% of Willow Run's workforce was African American, a higher proportion than any other major defense facility in the Midwest. The race against impossible numbers. The first months of production were a disaster. In September 1942, Willow Run produced 1 B-24. In October, it produced 3. In November, it produced 5. Reporters who visited the factory wrote skeptical dispatches. A columnist at the Detroit Free Press suggested the government had spent $112 million on a plant incapable of meaningful production. A senator demanded an investigation. The War Production Board sent auditors. Charles Sorensen, who had staked his reputation and his career on Willow Run's success, began his workdays at 5 a.m. and did not leave until midnight. The problems were not simple. Consolidated Aircraft's blueprints had been designed for San Diego's climate, where low humidity kept aluminum from corroding during assembly. Michigan's humidity created corrosion problems that had no precedent in aircraft manufacturing. Ford's engineers spent 3 months developing new surface treatments. The moving assembly line, which worked perfectly for automobiles, created new challenges for aircraft. A car body weighs 1,200 pounds. A B-24 fuselage section weighs 18,000 pounds. Moving it without deforming critical surfaces required equipment that didn't exist. Ford's tool designers invented it. The riveting process was the most labor-intensive operation in the factory. A completed B-24 contained 360,000 rivets. Each rivet required 2 workers, a bucker on one side of the aluminum skin, a riveter on the other, working in precise coordination. The fuselage contained spaces too small for adults. Ford hired workers under 5 feet 2 inches tall specifically for interior riveting operations. One supervisor later recalled that when he walked the fuselage line, he could hear the hammering from inside the aircraft but couldn't see the workers doing it. By March 1943, production had climbed to 75 aircraft per month. By June, it reached 190. By September, 231. The acceleration followed a curve that matched Sorensen's original projections, which the government had dismissed as fantasy. Workers who had struggled to install a single component in the correct sequence in their first weeks found themselves completing the same operation in half the time 6 months later. The line learned as it moved. 1 bomber every 63 minutes. The morning of June 28, 1944, began like every other morning at Willow Run. The night shift had worked since 10 p.m. The day shift arrived at 6 a.m. Overhead cranes moved fuselage sections from one station to the next. The smell of machining oil mixed with the smell of fresh aluminum and the ozone scent of electrical connections being made. The noise was constant, riveting hammers, pneumatic drills, the low hum of inspection equipment. At 3:17 p.m. that afternoon, a B-24 Liberator designated as aircraft number 6792 rolled off the end of the assembly line and was towed to the flight ramp by a small tractor. The towing took 4 minutes. An inspector signed the completion form. A test pilot climbed into the cockpit for engine checks. The aircraft was perfect, all 1,550,000 parts in their correct positions, all 360,000 rivets properly set, all 8 miles of wiring connected without fault. That aircraft had been preceded by another 163 minutes earlier. And before that, another. And before that, another. For the first time in history, a factory was producing a 4-engine heavy bomber at a rate of 1 per hour, around the clock, every day of the week. The rate that Charles Sorensen had promised in 1941, the rate that his own engineers had called impossible, had been achieved and maintained. The numbers accumulated in a way that defied easy comprehension. In the final 18 months of the war, Willow Run produced 8,685 B-24 Liberators. Each one weighed 36,500 pounds empty. Each contained enough aluminum to build 30 automobiles. Each required 1.2 million man-hours of labor spread across every factory in the production system that fed Willow Run with components. The wings came from a plant in Chicago. The engines came from Pratt & Whitney in Hartford, Connecticut. The turrets came from a manufacturer in Brooklyn. The bomb bay doors came from a metalworks in Cleveland. Willow Run was not a factory. It was the final assembly point of an industrial ecosystem that employed, directly and indirectly, more than 900,000 American workers. The men who flew what the workers built. Second Lieutenant Harold Fisher of Dayton, Ohio, received his B-24 at Willow Run on November 3, 1943. He was 22 years old. He had completed his crew training at Davis-Monthan Field in Arizona, and his crew, 10 men from 6 states, had learned to function as a single organism inside a 4-engine aircraft. Fisher knew the B-24 systems the way Willow Run workers knew their assembly stations, completely within a defined domain, partially outside it. What Fisher did not know, what the military explicitly did not tell combat crews, was the name of the factory that built their aircraft. Security protocols prohibited it. The reasoning was that knowing the source of their equipment might allow enemy intelligence to target production facilities. So Fisher flew missions from his base in Italy without knowing that his B-24 had been built in Michigan by a woman named Dorothy Knapp, who had left her job as a department store clerk in Flint to come to Willow Run, and who had driven 8,000 rivets into his aircraft's right wing before he ever saw it. Fisher completed 51 combat missions. His B-24 was shot through the tail by flak over Ploiești, Romania, during the August 1, 1943 low-level raid, one of the most costly bombing missions in American history. The aircraft returned to base because its structure held. Whether the structure held because of good design, good materials, or because Dorothy Knapp's rivets were set with the precise pressure that quality control required is a question that aeronautical science cannot entirely answer. It held. Fisher landed. He flew again the next day. Of the 18,000 B-24 Liberators built during the war, 6,000 were lost in combat. Another 2,000 were lost to accidents, mechanical failure, and weather. The remaining 10,000 flew until the war ended, then were surplused, scrapped, or stored until corrosion reclaimed them. Today, 2 complete B-24s survive in flying condition anywhere on Earth. The others are gone, aluminum and steel redistributed into cookware, automobiles, and building materials in the post-war recycling that stripped American airfields of their history. What production did to the war? In August 1943, the 8th Air Force lost 60 bombers in 2 days of attacks on ball-bearing factories in Schweinfurt, Germany. The loss rate, 20% of aircraft dispatched, was unsustainable. Military planners calculated that if every mission cost 20% of participating aircraft, the 8th Air Force would be mathematically eliminated within 6 months. The bombing campaign seemed headed for catastrophe. What saved it was not tactics, not strategy, not courage. What saved it was production. While commanders debated the Schweinfurt disaster, Willow Run was completing a new B-24 every 63 minutes. While crews were being trained as replacements for the lost air crews, the North American Aviation Plant in Inglewood, California, was completing a P-51 Mustang long-range escort fighter every 17 minutes, a fighter that would eventually solve the escort problem that made deep penetration bombing so costly. The Axis powers could shoot down individual aircraft. They could not shoot down the rate of production. German industrial planners understood this before most Americans did. Albert Speer, Germany's armaments minister, wrote in his memoirs that the decisive factor in the air war was not the performance of individual German fighter pilots, many of whom were superior to their American counterparts in experience and technique, but the arithmetic of replacement. Germany could produce 1,500 fighter aircraft per month at peak capacity. America produced 4,000 combat aircraft per month by mid-1944. The gap was not tactical. It was industrial. It had been decided in factories before the battles were fought. By the summer of 1944, the American aircraft industry, 66 companies operating 477 plants across 32 states, was producing more aircraft per month than all Axis powers combined. The B-24 specifically became so numerous that its presence over a target was no longer remarkable. It was assumed. Aircrews who had flown in 1942 and survived remembered the sense of isolation, small formations in enormous sky, counting on one another because there were no others. By 1944, the formations stretched for miles. 1,000 bombers over Germany in a single day became routine. The Axis had no answer for it because no answer existed. You cannot shoot down industrial capacity. You can only try to outbuild it. Germany tried. It failed. The human cost of the line. The workers who built America's bombers paid a price that no combat citation recorded. The Willow Run factory in summer reached 104 degrees on the main floor. Workers on the riveting lines wore leather gloves that soaked through within an hour. The noise level averaged 92 decibels, enough to cause measurable hearing loss after sustained exposure. Workers who spent years on the line retired with impaired hearing that physicians of the era did not connect to occupational noise, and that the military had no mechanism to compensate. The housing situation near Willow Run became a national crisis within 6 months of the factory opening. Ypsilanti and Ypsilanti Township had 7,000 residents in 1940. By 1943, 40,000 workers needed to live within commuting distance of a factory that operated around the clock. The federal government built a housing project called Willow Lodge that contained 2,000 prefabricated units. Workers called it Bomber City. Conditions were difficult: shared bathrooms, thin walls, no insulation against Michigan winters. Workers on the night shift slept while day shift workers cooked and talked 2 feet away. Nobody complained loudly. The alternative was losing the war. The accident rate was, by modern occupational safety standards, appalling. Workers unfamiliar with heavy machinery were placed on production lines within 2 weeks of training. The pressure to maintain production speed created incentives to skip safety procedures. In 1943 alone, Willow Run recorded 3,800 reportable injuries. 11 workers died in on-site accidents that year. The factory's management knew the numbers. The government knew the numbers. Production did not slow. The calculation was explicit, if unspoken. The injuries in the factory were real but bounded. The casualties from insufficient aircraft production were potentially unlimited. The arithmetic was brutal. The math was right. What happened when the war ended? Japan surrendered on August 15, 1945. The Army Air Forces canceled $1.3 billion in aircraft contracts within 72 hours. Willow Run received its cancellation notice on August 21. Workers who reported for the evening shift that night were told the factory would wind down production over the following 8 weeks. Most of them had known it was coming. The war in Europe had ended in May. Rumors of contract cancellations had circulated since spring. Still, hearing it officially standing on a production floor that had been their entire world for 3 years hit differently than the rumors had. By October 1945, Willow Run was silent. The assembly lines stopped. The overhead cranes were locked in their final positions. The inspection stations sat empty. The flight ramp, which had seen a new B-24 arrive every hour at peak production, was empty except for a few aircraft awaiting final delivery to storage depots. The workers left. Within 6 months, 40,000 people had vacated Ypsilanti's wartime housing and dispersed across the Midwest. The town that had swollen to support a factory returned to something approaching its pre-war dimensions. The factory itself became a Kaiser Frazer automobile plant, then an industrial property, then a subject of preservation arguments. The main structure stood until 2013, when most of it was demolished to make way for a technology hub. A single section of the original building survives, preserved as a museum. It contains, among other artifacts, a section of B-24 fuselage with its original rivets intact. The rivets are indistinguishable from one another. That uniformity, the product of 42,000 workers performing the same operations the same way, shift after shift, year after year, was the entire point. The measure of what was done. When the war ended, American factories had produced 303,713 aircraft. Included in that total were 18,482 B-24 Liberators, 12,731 B-17 Flying Fortresses, and 15,117 P-51 Mustangs. The production had required 7 billion man-hours of labor. It had consumed 434,000 tons of aluminum. It had drawn workers from every state, every economic class, every racial background, not from principle, not from social progress, but from the absolute requirement that the numbers be met. General Henry Hap Arnold, commander of the Army Air Forces, summarized the air war's outcome in a single sentence in his 1945 final report: "We hit Germany from the air until her productive capacity collapsed, and then we sent the ground armies in to occupy what remained." The bombing campaign that Arnold described had been made possible not by the men who flew the missions, though their courage was real and their losses were staggering, but by the men and women who built the aircraft in factories that the enemy could not reach. Dwight Eisenhower, who commanded the Allied forces in Europe, was asked after the war what single factor had most determined the outcome. He named two things: the American road network, which allowed rapid movement of supplies, and American aircraft production, which removed the Luftwaffe from the skies over Normandy before the first soldier stepped onto the beach. Neither roads nor aircraft were built by generals. They were built by workers. The victory, Eisenhower implied, had been manufactured before it was fought. The Willow Run factory produced one B-24 every 63 minutes for 18 months. The workers who achieved that rate received their wages, their ration books, and the knowledge that their work mattered. Most of them never saw the aircraft they built in combat. Most never knew the names of the crews who flew them. Most went home when the contracts were canceled and found other work, other lives, other routines. The factory that had been the center of their world was converted, then deteriorated, then demolished. What remains is the number, 63 minutes. In the history of large-scale manufacturing, no comparable feat had been achieved before Willow Run, and none has matched it since in terms of the complexity of the object produced and the speed at which it was produced. A 4-engine heavy bomber, containing 1.5 million parts, built every hour of every day by workers who had never seen one before they started. The number is not a statistic. It is a monument to what happens when a nation decides that the impossible is simply a problem that hasn't been solved yet. The sun rises today over the site where Willow Run stood. The Michigan fields that once shook with the sound of riveting hammers and aircraft engines are quiet. A small museum preserves what can be preserved. The rest is gone: the building, the machinery, the workers, the aircraft they built. But in every history of the air war over Europe, in every account of why the Allies won, there is a number hiding in the data: 303,713 aircraft produced by a nation that had 700 in production per month when the war began. That number was built, one aircraft at a time, by people who showed up to work every morning knowing that somewhere, men's lives depended on whether the rivets held. The rivets held. The workers are gone. The number remains.